A CD stores information digitally. That means stores information in ones and zeros by using something like this. This is a picture of one. These over here are the bumps, and then you get the pits. And what happens is that laser light is shone down on it of a known wavelength, and the depth of these pits here are very specific, so that you get constructive and destructive interference. If I just go on to the next slide here, here is a picture of a laser light coming in. Now, laser light is all of one frequency. It's coherent light, and what happens is if it hits on the edge here, because this distance over here, this distance t, is 1/4 of the wavelength of light, by the time that it goes to and fro, it's actually the distance that it's going to be behind this ray, as in comparison to that one, the other one, will be half a wavelength. And so what happens is you get destructive interference. So you're actually going to get a weak signal here. There will be a weak signal, and when you get a weak signal, it corresponds to a 1. When light strikes over here and gets reflected, so if you're going to get that light there and that light there, because they come out in phase, you're going to get constructive interference, so you're going to get a strong signal, and that would correspond to 0. Now, this pit depth over here, as I mentioned already, it corresponds to 1/4 the wavelength. And you have to be a little bit careful of this. If you've got a refractive index, this is actually like a plastic. This is a silver, this is a metal layer here, and this is where the reflection comes, but this is like a plastic. And when light comes in, obviously the wavelength is actually going to be changed. Remember, we will basically have that wavelength would actually equal the wavelength in air divided by a refractive index. So if the refractive index here is 1.6, we can work out our wavelength from that, and then this pit depth over here will be 1/4 that wavelength. Now, the computer actually, well, the CD is read in a spiral. So what happens is that these pits and bumps are in a spiral. I'm drawing them much wider than what it actually is. Actually, this distance between these, along here, you would get a whole lot of pits and bumps. So you would get maybe your bumps along there, and the laser would actually read it. So obviously, as the laser reads, because you're getting further out here, this is actually going to be going faster. So the CD actually has to turn slower as you go further out. But the distance between these over here is about 500 nanometers. That's the distance between those. And so you're able to store all the information as the laser reads around like this. It's picking up it in terms of ones and zeros. The laser will flash its light at a very specific rate, and therefore the pits and the bumps are specifically placed to be able to take the information that's been read, and convert that into ones, zeros, and then your computer obviously changes that back into your analog signal. Now, the difference between a CD and a DVD is that with the DVD, the wavelength that is used is shorter, and so these pits and bumps can be smaller, and so you can fit more of them. And also what they have is they have multiple layers of these information. So because these are smaller, they can put multiple layers within a CD, and so more information can be read. Also, this gap here, this gap over here is also smaller in a DVD, so you can store a lot more information with a DVD than you can with a CD.